EIGRP topology exchange over a WAN, over a wide area network. So we talked about split horizon already and how on frame relay non-broadcast multi-access or frame relay multi-point interfaces, that could be an issue. For example, this is like what I drew on the whiteboard right here, where if a 1112 sends a routing update, 1111 will get it, but he's not allowed to turn around and reflect it right back out to 1113. So in that particular case where we don't really have to worry about routing loops, where split horizon is hurting us more than helping us, we can disable it, as you can see here with the command no IP split dash horizon EIGRP and then the autonomous system number. Now, one thing to be aware of, where they might try to get you on the certification exam, on an interface, you might see a configuration of a router that says no IP split dash horizon. That's it. You might be faced with a troubleshooting scenario of, well, how come these two routers aren't getting information? Well, if you type no IP split horizon enter, and it does let you do that, that has no effect on EIGRP. That's for like RIP, if you want to turn off split horizon for RIP. But if you want to turn off split horizon for EIGRP, you have to add the EIGRP keyword and the autonomous system number. So just make note of that there's two ways of disabling split horizon on an interface, but they act on different protocols. So this is what I was referring to earlier, that on non-broadcast multi-access media, such as a frame relay interface, an interface configured for encapsulation frame relay that's got the IP address right there on the interface. Non-broadcast multi-access. We talked about how it doesn't support multicast packets. So what does the router have to do? It has to make a copy of every multicast it wants to send and send those copies out on the individual PVCs. This can cause links to saturate with EIGRP traffic alone. That's true if you're sending out lots of updates. Like if periodically your router has to send out, 50 update packets because he's just learned about 2,000 EIGRP routes, and now he's got to take those 50 update packets and copy them 25 times because I've got 25 neighbors that are reachable on this one frame relay interface. That could cause that link to be saturated with EIGRP. So one thing that the designers of EIGRP did to try to circumvent this problem is they built into the protocol this last bullet right here that says EIGRP will take a look at the bandwidth setting of an interface, divide it in half, and EIGRP will say, I can use no more than half of that bandwidth. No matter how much stuff I need to send at any given time, only half of that bandwidth is available for me. Now, of course, you can use the bandwidth command to modify that. And sometimes the bandwidth that EIGRP assumes on an interface might not really be what's available to it. It might have something less available to it. And we'll talk about that in just 1 second here. So look at this last bullet point. On a point-to-point link. So imagine this for a moment. Let's draw this. Let's say I have, let's just get rid of router C here for a second and say we just have a point-to-point frame relay connection between A and B. Okay, let's say that this actual physical serial interface is a T1. Now you should be able to know from the exam what the link speed is of a T1. What's the maximum rate that a T1 can operate at? That is 1.544 megabits per second. So in frame relay terminology, we would call that the access rate. The access rate being the fastest physical line rate my cable can go and everything connected to that cable. But we know that with frame relay, One of the other things you get to select when you're setting up your frame relay with your provider is something called a committed information rate. And the committed information rate is the rate at which the provider needs to guarantee you that they will always transmit your traffic and never drop it. Well, of course, your service provider would love for you to set your committed information rate to be the same as your access rate. Why? Because the more your committed information rate is, the more they can bill you every single month. But you might not need that. You might say, well, in this particular case, even though I've got 1.54 megabits per second available to me, I don't need that at all times, and I don't want to pay for that at all times. So I'd only like to have 256 kilobits per second as a committed information rate. Okay, great. Well, Frame Relay now knows that. You know, if you configure it in the router appropriately, and the Frame Relay service provider configures it, everybody knows that. But EIGRP doesn't know that. Your routing protocol has no visibility to this. What does your routing protocol do? When your routing protocol gets activated on a router, he basically does this. He says, okay, show IP interface brief. Let me make sure I'm looking at one here that has what I want. Okay, so if I want to activate Frame Relay on my serial 000, if I want to activate EIGRP on that, EIGRP will do the equivalent of show interface serial 000, and he'll extract from this the bandwidth. And a serial interface by default has a T1 speed bandwidth, 1.544 megabits per second. And so EIGRP will say, oh, great, I get half of that. If I ever got a ton of routing updates I need to send, I can use up to 750 kilobits per second. And you say, oh, but wait a second. You don't really have that. You've only got, well, what happened to my drawing? Oh, it's down here. You've only got 256 kilobits per second. EIGRP doesn't know that. So if I want EIGRP to have half of this, 256 kilobits per second, I don't want to have half of the actual line rate, well, I've got two options available to me. I could use the bandwidth command. I could go onto this interface and say bandwidth 256. Make it equal to my CIR. And that's what this slide right here is talking about. That's what the last bullet point is. On point-to-point links, ensure that the bandwidth is set to the committed information rate of that one PVC. And then EIGRP will take no more than half of that. Or alternatively, I could use the command above that, the bandwidth-% command. I could say, well, let's see here. If I just want to let EIGRP believe that this is 1.54 megabits per second, but I don't want him to have any more than, 154 kilobits per second, basically 1/10 of this, then I could say bandwidth percent 10, like we see here. IP bandwidth % EIGRP, the autonomous system, and the number 10. Give him 10% of the actual line rate. It's up to you which method you'd prefer. What about a multi-point interface? It's got multiple PVCs on it. Well, then you're going to want your EIGRP bandwidth, to, as it says here, to be the sum total of all the virtual circuits on that interface. Now, of course, when you add up all the virtual circuits, they can't exceed the actual line rate of the physical interface. That wouldn't make any sense. But you're going to want to add up the CIR of every single PVC, and then make sure you set your bandwidth command to be that. And then how does EIGRP treat that? Well, for example, if I have this router right here, and he's got one physical interface, but that physical interface has let's say 4 PVCs. Here's one, the red one. Here's another one, the green one. Here's a third one and a fourth one. Okay, and if I take a look at my commit information rates, I say, okay, this one is 100 kilobits per second. And this one right here is also 100 kilobits per second. This one down here is faster. Maybe that's going to my corporate office. And this one down here is also pretty fast. Okay, well, if I add up all of those, then I'm going to get 600. So on my interface, then what I would want to do is I'd want to type the bandwidth command to be bandwidth 600. Now, how is EIGRP going to react to that? He's going to say, okay, 600. Then for 600, he says, I'm going to divide that between all the interfaces. He says, well, I've got, well, I should say all the PVCs. So he says, well, I've got 400 PVCs. I'm sorry, getting distracted here. I've got 4 PVCs. So if I take that bandwidth, that gives me an average of 150 kilobits per second for each PVC. And then what I'm going to do is I'm going to take that and divide that by half. EIGRP will use up to 75 kilobits per second per PVC. So just to recap, I set the bandwidth to the total of my committed information rate for all of my permanent virtual circuits, which was 600 kilobits per second. Then the way EIGRP looked at that was he divided that by the total number of PVCs, which was 4 PVCs, coming up with 150. They said, okay, 150 divide that by 2, I get 50% of that. EIGRP said I can now have up to 75 kilobits per second per PVC. So here's an example of this. So it says here, if we just left it with the bandwidth command, pretend for just a moment that we did not have the bandwidth percent command. Then normally EIGRP would say, okay, well, if the bandwidth is 100, I'm going to get 50% of that, or 50 kilobits per second, and then divide that between these 2 PVCs. But in this case, he says, I'm giving you 10%. So we see here, he gets 10% of the bandwidth, which is 10 kilobits per second, and then he divides that between the PVCs. And that's pretty much all we have to say about how EIGRP utilizes bandwidth across WAN interfaces, specifically non-broadcast multi-access and multi-point interfaces. One other thing I'll mention about this, you might say, well, looking at this, I've got 2 connections. I've got 2 PVCs, DELC 102 and 103. What if I want to give EIGRP different bandwidth quantities on each PVC? In other words, what if I want DELC 102 to have up to, 200 kilobits per second allowed on that one for EIGRP usage, and on DELC 103 I want him to have up to 100 kilobits per second. I want to make it different for each neighbor. On a multi-point interface, you can't do that. On any interface that terminates 2 or 3 or more neighbors, there's no way for you to distinguish that one neighbor is treated differently by EIGRP than another neighbor. You can't do that. If that's what you want, you have to go to point-to-point interfaces. Okay, so in our next video, we're going to be covering EIGRP feasible distance and reported distance.